Warpage is an out-of-plane change in shape that occurs as the result of parts not shrinking uniformly. We see warpage in two ways: bowing and twisting. Take a look at this rectangle. Bow occurs when the part begins to bend out of plane. When the rectangle is not warped, the entire rectangle resides within one plane. When the rectangle bows, the four corners of the rectangle are still in plane relative to one another. The center of the rectangle, however, moves out of plane into the bow shape. Twist occurs when a section of the part rotates out of plane. Take a look at this rectangle. If the rectangle has three corners still in plane, but the fourth corner is out of plane, then the rectangle is considered twisted. All warpage occurs because the part does not shrink uniformly. When a part shrinks uniformly, that is, the same amount in all directions, then it shrinks in size but maintains its overall shape. When parts do not shrink uniformly in all directions, stresses build up in the part and cause the part to change shape. The larger the difference in shrinkage, the more drastic the warping. All injection molded parts have non-uniform shrinkage and therefore warp. The question is the amount of warpage acceptable? There are three main causes we can attribute to warpage: differential cooling, differential shrinkage, and orientation effects. Differential cooling relates to how the part cools from the cavity side to the core side. The larger the mold temperature variation is between the cavity and the core, the more influence there is on warpage. Differential cooling causes parts to bow or bend towards the hot side. Notice this shelf part. The leg closer to the gate shrinks less than the leg towards the end of fill. This is because it packs with more material, reducing its ability to shrink. The difference in shrinkage between the legs is called differential shrinkage and causes the part to warp. Orientation effects refers to the alignment of the plastic molecules and fibrous fillers within the material. As the paperclip fills, the molecules within the material align themselves. The material shrinks both parallel and perpendicular to the alignment. How much the paperclip shrinks in each direction depends on the material and the overall molecular alignment. Deflection results give you an indication of whether the warp is bow, twist, or a combination of both, as is the case for most injection molded parts. Use the examine tool to determine how far sections of the part have moved or deflected from their original locations. It is important to understand shrinkage and warpage are different, but they are closely related. Whereas shrinkage is a change in size, warpage is an out-of-plane change in shape, brought on by different changes in size. Whether your part is warping or shrinking is up to your interpretation. To help you interpret the deflection plots, several tools are available. One of the most useful tools is the anchor plane, which is discussed further in the next video.